Hello friends, let's do some more examples. Today I would like to show you the approximation of the cubic root out of x plus delta x, and the formula is that would be approximately, well, the value of the function at x plus some increase, and this increase would be a derivative. What is a derivative of a cubic root out of x? Well, this is x to the power of a third, and we can put a third in front. We got x to the power of minus 2/3, and that would be basically 1 divided over 3 times cubic root out of x squared. So this is exactly the change, and well, this is the value that we are going to get away from x, and that's why this is the formula we are going to approximate some values with. And once again, this is the Taylor series that we are working with, we're applying. And well, let's see some examples. What is a cubic root out of 10? Well, I can write it again as a cubic root out of 8 plus 2 in order to get to this formula. And this would be approximately a cubic root out of 8, which is great. I wanted to have it because I can compute it. Now this is 2 divided over 3 times a cubic root out of x itself is 8 squared. So this is 2 plus, what do we have here? A cubic root out of 8 is 2, squared 4. I can cancel it. It's going to be just 2 here, so 1 divided by 6. So 2 and 1 divided by 6. That's approximately the value of the cubic root of 10. These are 13 divided by 6, as you can see. And if I multiply it 3 times, I should get near to 10. Is that the case? Well, I got 216 in the denominator. I got 169 times 13 here. Well, you see 170 times 13 would be 1910, which I don't have. It would be 1897 if I'm right. Well, it's not quite 10, of course. I should get further, but this is an approximation, and that's fine. I mean, if I want to get a better result, I have to increase the number of steps. So this is just a very close approximation, then a very, very simple approximation. We can go on and get better results for sure. All right, what about the cubic root out of 70? Well, I can write it as the cubic root out of 64 plus 6, and let's apply the formula again. So this is the cubic root out of 64 only, plus then we have 6 divided over 3 times the cubic root out of 64 squared. That would be 8 plus 6 and 3 can be cancelled. This is 4 squared is 16. It's 1 divided by 8. So 8.125. I'm not going to do the computation again, but this is the way it's supposed to be working. So if we multiply it 3 times itself, is that the case? No, it's not. If I multiply this 3 times itself, I would get to a huge value. I should put a cubic root, not a square root. This is 4 and 1.25. That's all right. Okay, so this is what we get. And this is truly the case. If I multiply 4.125 3 times itself, I'm going to get around 70. That's all right. And last example is the cubic root out of 200. How is this one working? Well, let's take a cubic root. Which value is close? Well, I have 6 cubed, it's 216. It's too far away. Well, I have to go with 5, right? So it's 125 plus 75. I cannot find any value which is closer, so that's all right. So this is a cubic root out of 125 plus 75 divided over 3 times cubic root out of 125 squared. All right, so we're gonna get 5 here. I'm not making the same mistake I've done before. 75 and 3 gonna give me 25. Cubic root out of 25 is 5, and squared it's 25 again, so these two are cancelled as well. So that would be 1. So that's around 6. Well, 6 cubed is 216, so it's not that fine. But this is a very good approximation if you think that people had no calculators in medieval times. That's a huge advantage applying the Taylor series. All right, guys, thanks for watching and see you in the next video.